All right, guys, welcome back. This is Mrs. Rubright with Advanced Geometry. Today's lesson is on symbolic notation and truth tables on page 86 in your textbook. So the first thing I want you guys to do is copy the for-year notebook on page 86, which basically is this, and it's just going over your symbolic notation. So just a quick review. A conditional statement is if P, then Q, which is written symbolically. In symbolic notation, you would write it if P, arrow Q, which means if P, then Q. Your converse is if Q, then P. So if Q, then P. It's Q, arrow P. This is how you write it in symbolic notation. Your inverse, if not P, then not Q. So it's a little squiggly line, not P, then not Q. Contrapositive, if not Q, then not P. And then your biconditional, P, if and only if Q. So on tomorrow's quiz, on Monday, on your quiz on 2.1 to 2.3, you are going to have an extra credit, which is to write the symbolic notation for one of these. So if you know these, you should be able to get the extra credit. All right, so we are going to go over some truth tables. So that is going to make the truth table for the conditional. So I would have a P, a Q, and I would have for conditional, if P, then Q. So on all truth tables, we always start out with the same thing for our P's, because it could either be true or it can be false. So we always start out with true, true, false, false. Because if our P is true, our Q can either be true or false. If our P is false, our Q could either be true or false. And this is the 4 different possible combinations of true and false. So we always start our P's with true, true, false, false, and we always start our Q's with true, false, true, false. When we're going from P to Q, the only time that it's false is if true goes to false. It is only false if true goes to false. It's only false if you have a true hypothesis and a false conclusion. Okay, so it's always only false if true goes to false. So true goes to false here. This is false. Everything else is true. So my answer is going to be true, false, true, true. And that's our conditional. Our converse. We always have our P and our Q. Converse is if Q, then P. It's the flip-flop, because Converse are like Chuck Taylors. It's shoes. Flip-flops are shoes. So we remember our P then Q becomes Q then P. We flip-flop. True, true, false, false, true, false, true, false. We always start with the same P and Q. On this one, we're going from Q to P. So right here, I'm going from true to false. So this is false. Everything else is true. It is only false when true goes to false. And we're going from Q to P. Inverse. So for our inverse, we need a P, we need a Q. Now we need to think, what is inverse? Inverse is not P, then not Q, right? So I'm going to need a not P, I'm going to need a not Q, and then I'm going to need a not P, then not Q. So my P's are always true, true, false, false. My Q's are always true, false, true, false. What do you guys think for not P? Take my P's and make them opposites. True becomes false, true becomes false, false becomes true, false becomes true. Right? Just flip my opposites. Opposites of my P's. Now do opposites of my Q's. Instead of true, false, I'm going to do false, true, true. Right? Switch everybody. So for inverse, I'm going from not P to not Q. Am I ever going from true to false? Right here. So true, true, false, true. contrapositive. If not Q, then not P. So I'm going to need P, Q, not Q, not P, not Q to not P. Try to do this one. See if you guys can get it. Try to do your contrapositive. See if you guys can fill it out, and then I'll do it. And see if you guys got it. Our P is true, true, false, false. Q is true, false, true, false. Negate your Q's, make them the opposites. So false, true, false, true. Negate your P's, make them the opposite. False, false, true, true. Now I'm going from not Q to not P. Am I ever going from true to false? The second one, right? So it's going to be false. Wait, it's only false if true goes to false, right? So it's true, true, false, true, true. True, false, true, true. It's only false if true goes to false. So now, page 87, number 1. Describe how to use symbolic notation to represent the contrapositive of a conditional statement. If not Q, then not P. For 2 through 5, we're going to do these out loud together as a class. Let's put this up here. So number 2, if P then Q. Can somebody tell me how to say that in words? If P then Q, using this. Fabulous, amazing. So she said if polygon ABCDE is equiangular and equilateral, then polygon ABCDE is a regular polygon. Perfect. Number 3. This is not P. How do I say that? Anybody? Yes? Perfect. So polygon ABCDE is not both equiangular and equilateral, right? It's not both equiangular and equilateral. All right. For number 4, if not Q, then not P. So the contrapositive, right? If not Q, then not P. Who wants to try this one out? Okay. Perfect. She said if polygon ABCDE is not a regular polygon, then polygon ABCDE is not equiangular and equilateral. Wonderful. All right, and then number 5. P if and only if Q. P if and only if Q. Aiden. So read P. Polygon ABCDE. If and only if. No, it's just, okay. So polygon ABCDE is equilateral and equiangular if and only if polygon ABCDE is a regular polygon. And that's how we write it in words. Making truth tables. So we're going to do a truth table, number 6, for if P, then not Q. So we're going to need our P's, we're going to need our Q's, we're going to need our not Q's. And then we're going to need if P, then not Q. So our P's, true, true, false, false. Q's, true, false, true, false. Not Q. Negate these. False, true, false, true. We're going from P to not Q. Am I ever going from true to false? Right here. So this is going to be false, true, true, true. Yes, always, always, always. Number 7, if not P, then Q. If not P, then Q. So I need a P, I need a Q, I need a not P. I need a not P, then Q. True, true, false, false, true, false, true, false. Not P's. Switch my P's. I'm going from not P to Q. Am I ever going from a true to a false? I am on the bottom. True, 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 false. We're going to do one more of these. Let's do number 8. If not, in parentheses, P to Q. So I have my P, I have my Q. And then I have my P to Q, if P then Q. And then my not, if P then Q. True, true, false, false. True, false, true, false. From P to Q. True, false, true, true, right? Negate it. False, true, false, false. Right? Just do my normal conditional, my normal if P then Q, and then negate it. All right, so I want you guys to go back to page 10, and I want you to look right here. Let me zoom in. I want you to copy this. So conjunction is and we can do that with like a little carrot top. Disjunction is or, which is a little v. Okay? For these, for your conjunction, your ands and your ors. For and, they both have to be true. This and that. I want you guys to do your homework and bring your first day papers back. And I'm not going to be happy unless I get both. Right? Or would be, I'm happy if you brought your homework or your first day papers back. One or the other. I don't require both. That's not true. But like this or that. Here's a better example. I would be happy if we went to the movies or dinner. Or the movies or bowling. So if we go to the movies, I'm happy. If we go bowling, I'm happy. Right? One or the other makes me happy. So with or, either needs to be true. So if there's at least one true, it's true. With your and, both have to be true. So with the and, both are true, it's true. Everything else is false. With the or, only one needs to be true. So true, 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 false. So let's do one of these. And I'm going to make a truth table for not P or Q. So I have my P's, I have my Q's. I have my P or Q. I have my not P or Q. And or is my V, right? All right, so P's, true, true, false, false. Q's, true, false, true, false. P or Q. Only one has to be true. Ooh, you guys can't see what I'm doing. Only one has to be true. And then the negate of that is switch all those answers, right? Negate this. False, 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 true. Making sense? So that is everything on symbolic notation and truth tables. I hope you guys enjoyed this little mini lesson. Have a great day. Like and subscribe to our channel.